Hello, welcome to today's lesson. Today's we'll be talking about chemistry practical. Chemistry practical is in two ways. It's divided into two, which the volumetric analysis and the salt analysis. But for this lesson, we'll be treating about the volumetric analysis, which we normally call titration. Traditionally for WAEC, volumetric analysis is always question 1, right? It's always question 1, which involves concentration. Good. So now let's dive into volumetric analysis. The basic things that you and I are supposed to understand. But before we do them, subscribe to this channel and also like this video if you found it interesting. Now let's go. There are 3 terms which you must fully understand in volumetric analysis, right? These are the 3 basic terms. Now let me write them for you. They are mass, mole, and molar mass. You see them? So these 3 terms has a what? They has a symbol and as well a what? A unit. Unit. Of course, based on our physics knowledge, we know that symbol and units, they are different, right? Good. Now let's see the symbol of mass. The symbol for mass is what? Just small m. And the symbol for mole is what? Small n. And the symbol for molar mass is capital MR. You see? These are their symbol. Please take note of this symbol because they are useful as we proceed, right? And also their units. The unit for mass is what? Gram. You see in chemistry practical, right? Good. The unit for mole is what? MOL. Do you see? And the unit for molar mass is what? Gram per mol. Gram per mole. You get it? So these are the symbol and what? Their unit, which you must understand, right? About these 3 basic terms. You get it? Please take note of this term. Now let me give you the formula that connects these 3 terms. There's a formula. We say mole is equals to amount of substance is equals to what? The mass upon what? Molar mass, Mr. This is the formula. Mole is equals to mass upon molar mass. You get it? Good. Now let's proceed to concentration. Of course, note, my primary motive here is to make you to understand the cracking aspects in this volumetric analysis, right? Good. Because that's, I think, one of the most difficult things. Now we proceed on concentration. Concentration can be expressed in 3 ways, which are the molar concentration, the mass concentration, and the percentage concentration, right? So anytime in chemistry practical that you see this talk about concentration, try to identify which type of concentration they are talking about, if it is molar or mass concentration. For this video, we'll be treating these 2 only, 1 and 2, right? Now let's proceed. The molar concentration talks about the unit for molar concentration is what? Mole per dm cube, right? You see it? And the unit for mass concentration is what? Gram per dm cube. Do you see it? Gram per dm cube. So anytime you see gram per dm cube, it talks about the mass concentration. Anytime you see mole per dm cube, it talks about the molar concentration. Is that clear? And is it understandable? Right? Good. Take note of these 3 things. Now we proceed. Now let's try to see how we analyze the formulas. Right? The first, now here in volumetric analysis, there are 5 main basic formulas which you and I should understand, right? And the first formula is the formula that connects these 3 terms, which is what? This one. We say mole is equals to mass of a substance in what? In gram upon what? Molar mass of a substance. You see it? Which is just equals to N is equals to M upon Mr. This is it. Mole is equals to mass of a substance in gram upon what? The molar mass of that particular substance. Take note of these formulas. This first formula, this is the first one, right? Now we move to the second. We talks about the molar concentration formula, which says molar concentration. Now we abbreviate concentration as CONC. This is concentration in chemistry. That's how we abbreviate it, right? Good. Molar concentration formula is just equals to what? The mole upon what? Right? Mole upon volume should be what? In dm cube. So that means the volume should be converted to dm cube. So the molar concentration formula is what? Mole upon volume dm cube. Do you see here the mole? Good. That's the second formula which you have to understand. Right? Molar concentration. And this is the unit of what? Molar concentration. You get it? Secondly, or the third formula now talks about what? The mass concentration. Right? Is what? Is gram, in other words, mass upon what? Volume dm cube. In other words, the volume should be in dm cube. The mass upon volume dm cube. You get it? This is just equals to what? Mole upon what? Dm cube. That's it. Here again is just equals to gram upon dm cube, because the volume should be in dm cube, their unit. You get it? Good. That's what you should first understand. Right? Now what's next? We talk about the fourth formula. The fourth formula we talk is the Cavard method. Right? The Cavard method. Now the Cavard formula is what? CaVa, because that's Cavard upon CbVb is equals to the number of mole of the A and the number of mole of the B. Now C here represents concentration of the acid. A is the acid. V represents volume of the acid. B here represents what? Base. Concentration of the base, volume of the base, equals to the mole ratio of the acid, the mole ratio of the base. Do you see how to understand it? I hope it's clear. Good. Thank you. Again, we proceed towards the fifth formula. The fifth formula is the molar concentration just equals to what? The mass concentration upon what? The molar mass. This is the fifth formula, which can also be expressed as what? Mole per dm cube just equals to what? Gram per dm cube upon gram per mole. You see it? It can also be expressed this way. So this is the fifth and the last formula we'll be discussing in this video, which you must understand. In the next video, I'll be talking about percentage impurity, solubility. Do you see? Good. Now, these five formula, I want you to understand them. We'll be using different formula just to arrive in a particular quantity that the question asks us. So you must be able to understand these five formula and how to use them. Right? Is it clear? Now let's talk about how to convert formed centimeters cube to dm cube. How to convert volume from centimeters cube to what? Dm cube. Now if you want to convert any volume from centimeters cube to dm cube, what are you going to say? It's very simple and easy. Always divide by 1000. Take note. If you want to convert 25 centimeters cube, right, to dm cube, what are you going to do? Just say 25 divided by 1000. You see? Which give us what? 0.25 dm cube. You see? So this 25 centimeter dm cube is just equals to 0.25 dm cube. So any volume you want to convert from centimeters cube to dm cube, just divide by 1000. I hope it's clear. That's it. And it's very simple. All about the logic here, it's depend on the formulas, how you use the formula, how you iterate the formula to arrive in a particular quantity or particular answer, right? Good. Now let's proceed to question solving. Right, to our first question. Let's proceed. Please, if you don't understand, before we proceed to the first question, make sure that you write all this formula. Try to understand them, memorize them, and know them just like how I know them. Do you see? Good. I recommend. Do it now. And also find a pen and a paper. Go along with me as I will be doing. Right? But before we start solving question, please subscribe and also like. Thank you. Now this is our first question. Which says a dilute tetraoxosulfate 6 acid, right? B contain 2.15 gram of sodium hydroxide per centimeters cube, 250 centimeter cube of solution. In a titration experiment, 25.0 centimeter of B required 20.5 centimeter cube of what? A, to complete neutralization. Anytime you hear neutralization in a particular chemistry question, it means it's a reaction between acid and base, right? Write the equation of the reaction and find A, the concentration of B in mole per dm cube. So mole per dm cube, based on our previous explanation, it means what? The molar concentration. B, concentration of A in mole per dm cube. That's again. And C, concentration of B in gram per dm cube. Good. I hope it's clear. Please pause the video and write this question and solve along with me, right? Thank you. Now let's move. The first thing the question told us is to write what? The equation of the reaction. The equation of the reaction is what? Between tetrahydrosulfate 6 acid and what? Sodium hydroxide. If you read the question. So now we are going to say what? H2SO4. This is tetrahydrosulfate 6 acid plus sodium hydroxide, NaOH, right? To produce what? Sodium sulfate, Na what? 2SO4. This is sodium sulfate, and water, H2O. So we put here 2, we put here 2. So this is the equation of the reaction, right? Therefore, sodium sulfate react with this, and also this one react with this. They form water. I hope it's clear. So this is the equation of the reaction. That's what question. The first thing say. Second says what? Find what? Concentration of B in mole per dm cube. So A, say concentration of B in mole per dm cube. Concentration of B in mole per dm cube. First of all, what is B on the question? Let us see the question. B contain what? 2.15 gram of sodium hydroxide. So you say you should know what is B. B is what? NaOH, sodium hydroxide. You get it? Now, what is the mass of B on the question? Is what? 2.15. So mass of B is what? 2.15 grams. So anytime they give you the mass, take note. Now what are we going to do? What is the volume of B? If you read, they give us 2 volume of B. But we are going to take first the first one, which is what? 250 centimeter cube. So say volume of what? Of B is what? 250 centimeters cube. You get it? That's the volume of B, which we must understand, right? Now what are we going to do? First of all, let's convert the volume from centimeters cube to what? Meters cube. So say 250, as I said, divided by what? 1000. You get it? Good. Which gives you 0.25 dm cube, right? So now we say equals to 0.25 dm cube. So now the volume we have converted. Always, as I explain in how to convert. You get it? Once we have converted the volume, what are we going to do? Now, the first thing here, we are supposed to find the concentration. What is the formula for concentration in mole per dm cube? We say concentration of B in mole per dm cube, molar concentration is equals to what? We say the formula that I gave you is what? Mole upon what? Molar mass. Sorry, volume dm cube. Do you see? Which is the same N upon V dm cube. But we don't have the mole, so we have to find mole. What are we going to use to find the mole? Now we are going to, the formula for mole is equals to what? Mass upon molar mass. Do you see? We are about to find the mole, so that we use this formula. What is the mass? They give us here the mass, which is 2.15. Now what is the molar mass? We don't know. We are going to use what? The chemical formula to what? To find the molar mass. So now let's go. So what is the mass? Mass is equals to 2.15. What is the molar mass? NaOH. The molar mass of sodium hydroxide is equals to what? Sodium is 23 plus, oxygen is 16 plus, hydrogen is 1, which gives us what? 40 gram per mole. If you don't know how to find molar mass, please go and watch my video. I'll be sharing the links on the description box. I precisely taught on that topic, how to find molar mass. Right? Good. 40 gram per mole. So since now we have the mass and the molar mass, we use the formula to find the mole. So mole is equals to what? 2.15 divided by what? 40. What is it going to give us? If we divide it, it's going to give us 0.05375 mole. This is the molar mass. Right? Now we know the mole. Now we know volume. Of course, we have converted volume to what? dm cube. Now we use the formula. Concentration of B is now equals to what? Mole first, which is 0.0537, right? 5 divided by what? Volume 0.25 dm cube. Here is what? Mole, right? Now if you use your calculator and divide, you are going to have what? 0.215 what? Mole per dm cube. You get it? That's it. If you use your calculator, find it now. May I have mine? Use it? Good. I have been calculating behind the scene. Now that's it. Now we have the concentration. Say therefore, concentration of B in what? Mole per dm cube, or the molar concentration of B is equals to what? 0.215 dm cube. Good. Mole per dm cube. Good. I hope it's clear. Now what are we going to do? We have find first one. Now we say what? Concentration of A in mole per dm cube. Now let's proceed. Mole per dm cube talk about the molar concentration of A. Good. How are we going to find it? Now if you look at the question, they only gave us the volume for what? Of A, which is the acid. So say volume of A is what? The volume of A. The volume of A is what? 20.5 centimeters cube. That's the volume of A. That's the only thing they give us. Just look at the question. That's the only thing. So anytime you have something like this, they only give you that particular thing, right? Only the volume of A. What are you going to do? Automatically that draw a mind to what? To the Cavall method formula, right? Since both of them are in the same equation, both A and B, they form the same equation, we can use the Cavall method to find the concentration of A, right? Now we know the volume of B, we know the concentration of B. We can use the Cavall method. Look here at the chemical formula. This is A, this is B. So both of them are in the same equation. Now we use the Cavall method, right? This is only one thing we know about A, the volume. So say Ca Va upon Cb Vb equals to Na Nb. Now what is the volume of A? Ca, which is the volume of A, is what? 20.5 centimeter. Sorry, we don't know what is Ca. We don't know. We say Vb, that's the volume of B, 20.5 centimeters cube, right? Now what is Cb, concentration of B? Of course, we have find it, right? So when we find, we have what? 0.215 mole per dm cube, right? Now we go again. Volume of B. Volume of B. What is the volume of B? Is the volume we use in the titration. Just read the question. It's 25.0 centimeter, right? 25.0 centimeters cube. That's the volume of B. Now, based on the chemical formula, we are going to find Na and Nb. It's molar ratio. The number behind the acid, which is A, is what? Is 1. The number behind the base, which is what? 2. Is what? 2. You see it? Based on the chemical formula, right? Now we proceed. We substitute into the formula. Right now we say Ca times what? 20.5 upon Cb 0.215 multiplied by 25, right? Equals to what? 1 upon 2. Use it. Now we cross multiply. Ca multiplied by what? 20.5 times 2, right? Equals to what? 0.215 multiplied by 25. Right, when we cross multiply. You get it? Good. Now let me just add. Now if we multiply here, we are going to have concentration of the acid is equals to what? 41, right? Is equals to what? Here we are going to have 5.375, right? Now we divide both sides by 41, divide here by 41. This cancels this. So concentration of the acid now become, if you divide it by 41, you are going to have what? 0.131 mole per dm cube. You see it? I hope it's clear and it's understandable. Good. Now always learn to leave your answer in what? In 3 decimal place, right? Good. Now let's see. Now let's come and solve the last question, which is concentration of B in gram per dm cube. That is the mass concentration. What are we going to do? Now this is it. Now let's look at the formula. Of course, for B, we have what? The mole per dm cube, we have the molar mass. So automatically we use this formula. This is what